All right, here we go. Quick video on chapter 3.5, binomial theorem, factorial notation. But this time we're going to talk about Pascal's triangle and how we can use Pascal's triangle to help us expand a binomial. All right, so let's look at some things we used to do in the past. We wanted to expand a plus b quantity squared. Then what we would do is we would, put those two together. We'd get a plus b times a plus b. And then we'd use the FOIL method, and we'd get a squared plus ab plus ba plus b squared. We'd combine those, and we'd get a squared plus 2ab. Well, that's not too bad to do in the beginning, right? Because it's only squared. Even if we went to a cube, what we could do is we could take a squared plus 2ab plus ab plus 2ab plus b squared times a plus b. And we'd get, if we distribute, we'd get a cubed plus 2ab plus ab squared. We distribute the b, we get a squared b plus 2ab squared plus b cubed. All right, so when we did all that and we add them together, we got a cubed plus 3, right? 2 plus 1 is 3a squared b. And we got plus 3ab squared plus b cubed. All right, a couple things I want you to do is stop and think about right now. What do you notice about the coefficients and the powers? How do they relate to the Pascal's triangle? Not the Pascal's triangle, but Pascal's triangle. It's not the, but anyway. What do you notice? Well, a couple things that I notice are this. One, this is a pattern. 1, 3, 3, 1, right? What do we else notice about the powers? What do the powers seem to do? The powers seem to go, well, a was cubed, then it went squared, then it went to 1, and then it went to nothing. Whereas the b went b cubed, b squared, b to the first power, no b. So when one is decreasing, the other is increasing. So it creates kind of like this V. External powers are the highest. As they move in towards each other, they get the lowest. Now what you'll also notice is that they always add up to the external power of 3. 3 times 0 is 3, or 3 plus 0 is 3. A squared, so 2 plus 1 is still 3. A to the first plus b second is still a total power of 3, and b cubed. All right. So when we relate that to Pascal's triangle, check it out. That 1, 2, 1 was a second power. Look, 1, 2, 1. Whoa. When we went to the cubic, we had 1, 3, 3, 1. Cubic is 3, 1, 3, 3, 1. And the fourth, end of the fourth, 1, 4, 6, 4, 1. So if we wanted to keep expanding this, what we would notice is that even down here, you would get a to the fifth, b0, so in this case it would be a to the fifth, b0, a to the fourth, b to the first, a cubed, b squared, a to the second power, b cubed, a and b to the fourth, and finally b to the fifth power. And in between there, of course, would be all the pluses, plus, 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 plus. And so that's basically how it works. This is great thinking he had there. Staying up late at night, probably working on this math stuff. Awesome. Now let's look at a little more challenging example here. A lot of numbers on the board, so I'm going to try and walk you through it slowly so we can see it. And hopefully we can see the whole thing. Come over here a little bit more. There we go. All right. So here we're asked to expand 2x minus 3 to the fifth power. So what do we do first? Well, we start by listing all of our coefficients that we know from the basic of Pascal. 1, 5, 10, 10, 5, 1. Then we simply take the A, and I like to color code it just because I can see things better. A, we go A to the 5th, A to the 4th, A cubed, A squared, A to the 1st, no A. Then B, we start off with B to the 0, B to the 1st, B squared, B cubed, B to the 4th, and B to the 5th. Now, since we have each one labeled, what we want to do is plug in those values. So 1, A is 2x, so we put the whole 2x to the 5th power. No B. 5 times 2x to the 4th power. Here's our first B, which was B. We put in our -3. Plus, our A is now cubed, so we get 2x cubed, and we get -3 squared. 2x squared times -3 cubed plus 2x to the 1st power, -3 to the 4th power, and finally 1 times -3 to the 5th power. All right, so we have it there so far. Now what we got to do is expand it a little bit more. We have 3x to the 2x to the 5th becomes 32x to the 5th. Sneak in there. Plus 2 to the 4th is 16, and that's x to the 4th. Remember, this 4 applies to both the 2 and the x. We can't forget that. All right, that's a mistake we students make every once in a while. -3 times 10. 2 cubed is 8, and x cubed. -3 squared is 9. 10 times 2 squared is 4x squared. -3 cubed is -27. 2x by itself times 5. -3 to the 4th power is 81. And -3 to the 5th power is -243 times 1. All right, so our final stance here is 32x to the 5th minus, multiply 5 times 3 times 16, we get -240, x to the 4th, plus 9 times 10 times 8, 72 times 10 is 720, x cubed, minus 10 times 4 times -27 is a -1080, x squared. 5 times 2 is 10 times 81 is 810, x. And then minus 243. And that is your expansion of 2x minus 3 to the 5th power. All right? Encourage you to rewind that, go back through it. There's a lot of numbers up here. You might want to take some time to write it down. Practice it yourself and try another problem. Maybe you want to try something where it's just 2x minus 4 and see how that goes. All right, thanks a lot. Again, have a great night. Talk to you soon.